So in this problem, we're given the three doctors. I'm just going to list them by letters. Actually, Ramirez and Vu, SRW. And they are 30 minutes apart. Here for the first one, second 25 minutes, and then third is 50 minutes apart. And the first appointments begin at 8 a.m. Question is, other than 8 in the morning, that's when they start, and what times before 1:30 p.m. in the afternoon do all three doctors schedule their appointments to begin at the same time? So this is immediately recognize this is a least common multiple problem because we're looking at the same time or in so this would continue. So for example, for Dr. Schwartz, it would be 30, 60, 90, so on and so forth. Ramirez would be 25, 50, 75, so on and so forth. We want to see when do all three overlap. Before, and it has to be before 1:30. So if you look at the total number of hours, that is 5.5 hours. 1 hour is 60 minutes. So that's 330 minutes. So we're looking for numbers less than wherever they overlap. So first, the easiest way to do is to find the least common multiple of 30, 25, and 50. And the way I do this is, well, is you divide by some common number, so 5. And then you look for another common numbers. Again, I see 5, nothing in the 6. This is 1 and 2. Then 6 and 2 have 2 in common, so 3, 1. And then what you do is all these pieces left over you multiply. So that's going to be 5 times 5 is 25, times 2 is 50, times 3 is 150. So the first time they're going to overlap is at 150. The next is 300. Would be 450, but that would be outside that. So we're only looking at these two times. 150 is 2 hour 30 minutes, because that's 120 plus 30, which means at 10:30 a.m. they're all going to have their appointments. And then 300 minutes is divided by 60 minutes in an hour, so that's 5 hours. So 5 hours from 8 a.m. is 1 p.m. So those are the two times that they're going to begin their appointments at the same time. So that would be answer C and H. Now I do want to go over this. I mean, I don't go over the why that is, but I'll explain the least common multiple in another way. 30, 25, and 50. So we're trying to create the smallest number that would be divisible by all of these. So 30 is 5 times 2 times 3. So we're doing essentially the prime factorization. So I'll start with that least common multiple has to have these pieces for it to be divisible by 30. Now for it to be divisible by 25, I already have a 5. All I need to do is to introduce a 5. And now for this to be divisible by 50, well, it has to have 2 5s and a 2. Already have 2 5s and a 2, so that is it. So this actually might be easier. 5 times 2 is 10, times 15, 150. And then we kind of proceed with how I did this remaining problem. So the answer is C and H.